Hey Buford Middle School students, this is Mrs. Welborn and this is Unit 5, Filling and Wrapping, and we are in Part 1 still, which is Shapes. And today we're going to talk about Lesson 3, which is Volume. Okay, and volume, we have an essential question, and volume, which we're going to discuss here, or EQ, is how can I find the volume of different shapes? And so much like the previous lesson on area, this is going to be about you choosing the correct formula, plugging in the values, and computing. Okay, if you haven't already, you need your guided notes. You need to be in a quiet place. You need to have a pencil so that in case you need to do any erasing, and of course you need to be able to pause your video. So keep all those important things in mind. Okay, let's get started. The volume of a solid, this is a vocabulary term, and you only have one vocabulary word here, so that's nice. The volume of a solid is the amount of space it contains. Volume is measured in cubic units, such as cubic feet and cubic meters. And so I'd like you to grab a highlighter, or in the very least, if you don't have a highlighter, maybe a colored pen. And we're going to do some highlighting here of some of the most important parts of this vocabulary. All right, so let's see. This is the area that you want to make sure that you're writing down. The volume of a solid is the amount of space it contains, and volume is measured in cubic units. Okay, that's going to be really important. That's the part that you need to have in your vocabulary. If you need to pause the video, go ahead and do that to make sure that you're filling all that information in. Okay, let's get started with our first shape, and our first shape is the rectangular prism. The volume V of a rectangular prism is the product of the length, width, and height. There's a couple things that I want you to add to your notes here. All right, and I got my pen out, and so first thing I want you to do is put this V in parentheses, and because I just want you to read through it, I want it to look like this is the variable that we're going to use for volume. So volume will be V. The second thing is you're going to fill in product in your guided notes. The volume, which we represent with the letter V, of a rectangular prism is the product, that means to multiply, of the length, width, and height. All right, now what you're going to notice down at the bottom here is that you have two formulas. All right, volume equals length times width times height, or we have a second formula here, which is big B times H. All right, and in this case, big B equals the area of the base. Now, I want you to box in your notes this first formula, because this is the formula that you're going to see on your reference material, on your CRCT formula sheet, and on the formula sheets that you're going to be able to use in class. All right, we are no longer using the big B times H. All right, and if your teachers taught you this last year, it's still the same thing, but what's important to know is just that this is how it's going to look like on your reference sheets, okay? All right, second formula, second shape we're going to talk about is the triangular prism. And with the triangular prism, the volume of a prism is the product of the area of the base and the height. All right, so again, you have a little bit of filling in you need to do in your notes. The volume of a prism is the product, again, means to multiply, of the area of the base and the height. And again, two formulas. All right, again, we're not going to see the big B formula, so this is the one that you're going to be using. 1/2 length, width, and height all multiplied together. All right, now your teacher may teach you a little bit about rearranging these, and so I'm not going to do that now, but they may have you do that in class. All right, again, it's the same thing as the area of the base times the height of a triangular prism, but we're going to be using the formula that looks like this. And again, keep in mind that we're talking about the volume. This is the space inside, the amount of space inside. All right, so we have a couple examples. Let's go ahead and go through these two shapes. Okay, example 1 is finding the volume of a rectangular prism. And let's read this example together. It says, an aquarium shaped like a rectangular prism has a length of 120 centimeters, a width of 60 centimeters, and a height of 100 centimeters. How much water is needed to fill the aquarium? So how much water can we get inside? Again, I always teach my students about CUCC, and so CUCC, the C is meanings to circle the numbers and or variables. All right, so we're going to go through and circle important numbers and variables, and in this case we have 3 important numbers. All right, and then we also want to go through and underline some hint words or some keywords. All right, in this case, most of the time the keywords come in the very last sentence. That's telling us what the question's asking us about. How much water is needed to fill the aquarium? All right, so to fill it up, we're talking volume. So we got 3 steps here. The first step, we're going to write the formula. All right, and if we're following along, we will have volume equals length times width times height. Then we're going to go through and substitute in our values. All right, so volume equals, remember what you learned about anything you substitute in, you want to put in parentheses. All right, my length, if I read through my sentence or my question again, my length is 120, so I'm going to fill that in here. My width is 60, so I'm going to fill that in here. And then my height is 100, so I'm going to fill that in here. All right, and again, all multiply together. Okay, and now we just need to simplify. All right, so you can just multiply straight across. Now I've done the multiplication for us just to save some time in the videos, but this is something again that you would off to the side do your scratch work. And what you should find is the volume of this aquarium is 720,000 centimeters cubed. Okay, so this is our final answer. All right, example 2 in your notes is talking about the triangular prism. So let's go ahead and look at that. Okay, and it gives us a triangular prism, and again, it wants us to find the volume. So now we're going to go back to our notes and we're going to look for that formula. So the first step is to always write the formula. And remember, we're going to use the formula where we have 1/2 times the length times the width times the height. So this is how the formula looks. All right, and again, we're just going to go through and substitute in our variables. So again, plug it in, plug it in. So we have the volume equals 1/2, and then I'm going to substitute in here the length and the width. All right, well, the length is 10 and the width is 4. Okay, length times width. And then I'm going to go through and multiply that by my height. All right, now notice everything I have here is multiplying. So if I follow order of operations, I want to simplify my first set of parentheses. So this is going to simplify to 40. And again, I could bring it step by step so I don't make any mistakes. And then I can go through and multiply these two because these are whole numbers. This would give me 120. And then finally, I would multiply by the 1/2. All right, and 1/2 times 120 is going to be 60 I'm talking meters, that's my units. I'm volume, so I need to cube. So my volume is 60 meters cubed. All right, now remember, through the commutative property of multiplication, I can multiply these numbers in any order and still get the same answer. So I don't have to go left to right when I have multiplying or addition. I can, in this case, multiply these numbers because I think that's easy. I can do that in my head and then go back and multiply by 1/2. All right, let's start looking at a couple different shapes now. All right, and so this is the volume of a cylinder. All right, and again, volume of a cylinder is the area, is going to be the space inside. All right, and so we have to deal with the area of the base, and this is the number of units squared that covered the base, and the height is the number of layers of units cubed that fit in the solid. So that's kind of what we're talking about when we're talking about volume of a cylinder. All right, grab your highlighter or colored pen with you, and there's going to be some underlining that we need to do. So the volume of a cylinder, again, good idea to just put this in parentheses so we know that's the letter that represents, is the cylinder of a cylinder. Volume of a cylinder is the product of the area of the base and the height. And again, here's our formula. Please box this in. All right, so we have volume equals pi r squared times h. Well, pi r squared should look familiar. All right, pi r squared is the area of a circle. And since the base is a circle of a cylinder, we find the area of that, and then we multiply it by the height. And so that's how we kind of derive our formula for the area of a cylinder. All right, so let's go through and try one here. All right, find the volume of the cylinder, and it asks us to use 3.14 for pi. All right, so we'll go ahead and do that. First thing we're going to do is write our formula. All right, so our formula is volume equals pi r squared h, or pi times the radius squared times h. Let's go in and substitute our variables. All right, it tells us to use 3.14 for pi, so I'm going to go ahead and do that. My radius here from my center to my outside is 2, and I do need to square that. And the height, which is the distance on the side, is 3. So I've gone through, substituted in, put everything in parentheses, and now I'm just going to simplify. All right, so the first thing I need to do is my exponents. Well, 2 squared is like 2 times 2. That's 4. And if I were going to bring everything else down here. All right, and now I can go through and just multiply across. So if I were to multiply 3.14 times 4 times 3, I would get the volume. And in this case, I'm going to get 37.68. I'm talking meters, that's my units, and I'm talking volume, so I need to make sure that I am cubing that. Okay, so again, just as simple as plug it in, plug it in. All right, let's talk about a cone. We got a couple more shapes to go. Let's talk about a cone. All right, grab that highlighter again or colored pen because we got some underlining and filling in we need to do. All right, the volume of a cone is related to the volume of a cylinder in the same way that the volume of a pyramid is related to the volume of a prism. That is, the volume of a cone is 1/3 of the cylinder with the same base and height. All right, so this is a little bit of an explanation as to how we're relating a cone and a cylinder. Since we know the formula for a cylinder, we can relate that to the shape of a cone. All right, so that's just kind of a little background information for you. All right, let's go ahead and grab our highlighter, and we have a little bit of information we need to fill in here. The volume of a cone is 1/3 the product, again, product meaning multiply, of the area of the base and the height. Two formulas are given. One with the big B may look familiar if your teacher taught you that last year. All right, we're not going to use that this year. We are going to use this formula, and this is the formula that you'll see on your reference sheet. But just so you know, it is the same as the big B. All right, 1/3 pi r squared times the height. Okay, so we basically have a cylinder, and we're taking 1/3 of that because the third comes from the shape being a cone as opposed to a cylinder. All right, let's try an example. Many Native American tribes built teepees that were cone-shaped. A teepee has a height of 12 feet and a base diameter of 12 feet. Approximate the volume of the teepee. All right, so again, steps don't change. So we're going to have first write the formula. Well, the volume of a cone that we're going to use is the volume equals 1/3 pi r squared times the height, or h. Then we're going to substitute in. So I have 1/3. For pi, I'm going to use 3.14. My radius, all right, my radius is from here out. Since this is showing my diameter, which is 12, the radius is half of the diameter, which is 6. So my radius is 6. I need to remember to square that. And the height of my TP is 12. All right, and now I need to go through and simplify. So order of operations tells me to do the exponent first. So we'll end up 6 squared is 36. I can bring everything else down here. All right, and now I would go through and just start to multiply. Again, I would multiply my whole numbers first, and then I would probably multiply my decimal, and then finally do my fraction. It's okay to change this to a decimal if you want. All right, so that could be like 0.33. Anyway, if you do all of that multiplying, again, I'm not going to show you all the computation because I feel confident you can do that. You would get that the volume of this TP is 447.64 feet cubed. And it asks us to approximate, so this is a more specified answer, but you could say, 448. Maybe that's our approximate. 448 feet cubed is our approximate. All right, moving right along here, guys. Okay, volume of a pyramid. So now we have our pyramid. All right, the volumes of a pyramid and a prism with the same base area and the same height are related, meaning that the formulas are going to be similar. The volume of the pyramid is exactly 1/3 the volume of the prism. All right, and that may be helpful to remember. If you can remember that it's 1/3 of a pyramid, that could help you kind of pick out the formula. All right, let's look at our information and get our highlighter. Okay, the volume of a pyramid is 1/3 the product. So you're going to fill in product, and remember that that means to multiply, of the area of the base and the height. Okay? And again, let's see if I can scroll this up. All right, let me fill this in here. So we have the volume equals 1/3 the base, which here is going to be length times width, because our base is a square or a rectangle. All right, so the base is length times width, and the height. All right, so you want to add this to your notes if it's not in there already. So the formula we're going to use is volume equals 1/3 times the length times the width times the height. And the length and the width here is just the base, the bottom. All right, let's go through example 5. We're almost done. This is our last example. I know this is a little bit longer than we tried to keep them, but we had 5 different shapes here. Okay, this last one. The Rainforest Pyramid in Galveston Island, Texas is the home of many plants, butterflies, fish, and reptiles. This square pyramid has a height of 100 feet, and each side of its base measures 200 feet. What is the volume of the pyramid rainforest? All right, so again, we're going to use our same steps that we've been doing. So the shapes change and the formulas change, but the steps stay the same. So first thing we're going to do is write our formula. So we have 1 volume equals 1/3 times the base, which in this case, we have a base of a square or rectangle, square. So we have length times width, and we need to multiply that times the height. Okay, and then we're going to substitute our values in. So volume is 1/3. All right, we're going to substitute our length and our width. It tells us that that we have a square. Does it tell us we have a square? Yeah, sorry, square pyramid. Yep. So it does tell us that we have a square. So this is going to be 200 as well. So we're going to fill in our length of 200. We're going to fill in our width of 200, and then we're going to fill in our height, and our height is 100. All right, and now we're just going to go through and we're going to simplify. And so to simplify this, let me scroll this up. To simplify this, we always want to start with our parentheses following order of operations, and then we can go through and multiply by our whole numbers and then our fractions. And again, if you want to change this to a decimal, that would be fine. All right, but the volume in any case, I'm going to save you the computation, but the volume would be 1,320,000 feet cubed. All right, so sounds kind of harsh to keep plants, animals, and reptiles, but that seems like a pretty big amount of space to house them in. All right, guys, you have a couple your turn questions that go along with this, and here are 4 of them. You need to find the volume of each figure, and we would like for you to do it in the same steps that each example question was in. There is not going to be enough room on your paper in order to show all your work appropriately, so you are going to need a separate sheet of paper to do all your work. It would be great if you would transfer your final answers back onto your guided notes and then keep your scratch sheet of paper, your separate sheet of paper available for your teacher to see. Thanks so much for listening, and we'll go over these tomorrow in class.